on these three triangles, in chapter 1, we talked about classifying triangles by angles. So we had like obtuse, acute, and right. Okay, we didn't spend a lot of time on those, but we did mention them. Okay, now we're going to talk about classifying them by their sides. Okay, so if I'm looking at that first picture on the left, what can you tell me about that picture?
Small. Obtuse.
What do you mean? No angles involved.
Oh, it's like skinny.
Slanted?
Skinny.
Are any of the sides the same?
No.
No. So write down no sides are the same. Or no sides are equal. Okay. Since no sides are equal, can any of the angles be equal? No. So no angles are equal. Does anyone know what kind of triangle this is called? Starts with a S. Scalene. Yep. We are not going to spend a lot of time focusing on scalene, okay, but it's good to know. We're going to spend most of the time talking about the next two. Okay? On that second one, what can you tell me about that picture?
It looks like a triangle.
Okay.
Looks like two are the same length.
Bingo. Two sides are the same. Two sides are equal. What sides are they?
The pointy ones like this.
Yep, these ones that are connected, I'm going to call this point up here the vertex. Okay, 2 points connected to the vertex. So, since two sides are equal, how many angles are equal?
1.
2. Yep, 2 angles are equal. Okay, which angles are going to be equal?
The bottom 2.
Yes, it's the ones connected to the base. Okay, they're the two opposite from the vertex that's connected from the legs. Okay. These, I need to talk about these. These little tick marks, you're going to get used to them a lot and you're going to be using them. Okay, those mean congruent. Okay, same thing with these little arc symbols. Those mean congruent. Okay, so whenever you see those in pictures, you can assume that they mean congruent. Okay, what is this triangle called with two equal sides? Isosceles. Good?
Yep. Sure.
And then that last one, what can you tell me about that last
They're
one?
all the same.
All sides are the same. All sides are equal. Okay, so I can put a tick mark on all three, signifying that they are all equal to each other. Well, if all sides are equal, what do we know about the angles?
They're all equal.
All angles are equal. All angles are equal. So I can label all of the angles with their congruence markings. Is there anything else I can determine based off of that given information? Specifically with the angles. If I know all of them are the same.
They're all
It's a
30.
perfect triangle.
Not 30.
Not 30.
60.
Where'd you get 60 from?
Oh, these are
180 divided by
Right.
2.
All angles add up to 180 in triangles. So I can take 180 divided by 3 to give me 60. So all of these angles in this triangle, since it's equilateral, equals 60 degrees. Okay, that's going to be true for all equilateral triangles. All equilateral triangles have angles of 60. Okay, yes, this is an equilateral triangle. Comes from equal, means all equal sides. Lateral is sides. So equal sides. Okay. Okay. The two main ones that we are going to be dealing with are isosceles and equilateral. Okay, those are the two that we're going to be using the properties for. Okay. Go ahead and flip your notes to the next page. I want to look at example 1. Okay, example 1, you have this picture here. Ignore the line of symmetry down the middle. Okay, what kind of triangle is this? Isosceles or equilateral? Isosceles, how do you figure that out? How do you know?
Because 2 of them are the same length.
Right, it gives us these two congruence markings, so that means those two sides are the same. What else do we know about this triangle then?
The 2 angles are the same.
Which ones?
The bottom, right.
These two, right? The ones that are opposite that vertex that connect to the base. Okay? That's all I wanted you to figure out. Okay? They give us these, we figure out what kind of triangle it is, and then we use other information we know and apply it to the figure. Okay? So, looking at example 2, we're going to be getting into a lot of algebra here. Okay? On example 2, what kind of triangle is that on A? As in isosceles or equilateral? Isosceles. So we got that because these two sides are the same. What else can we assume?
The 2 bottom angles are the same.
Two bottom angles are the same. Okay? So, if one of them's 28, well, what's the other one? 28. Good. Okay, now let's actually answer the question now. What is the value of x? They give us this 5x plus 9. That's equal to that top angle. Okay? How can we solve for x here? We need to set up some sort of equation to get us there.
Add the two bottom angles.
Okay. Start there. What's 28 plus 28? 56. Okay?
Now you take that 180 minus that, and you put whatever that is, and then equal that to that.
Okay. You're exactly right. What are you thinking over there?
I was thinking more 56 plus 9 plus 5x equals 180.
Yep, and that's exactly what you said. You just kind of took it a harder route over there. Okay, so we're going to set up an equation. We know all three of those angles should equal what? 180. So that's exactly what I'm going to do. 5x plus 9 plus, it would be 28 and 28, but we said that's 56 equals 180. So I took all the angles, added them up, set them equal to 180. Okay, so now it's just an algebra problem. What can I do here? Combine like terms. I have 5x plus 65 equals 180. Two-step algebra. Subtract 65. So I have 5x equals, yep, 115. One more step. Divide by 5, x equals 23. Okay. All it wanted us to do was find the value of x. If it wanted us to find this specific angle right here, how would we do that? If it wanted us to find, you would plug it back in. Yep, but it didn't want us to do that, so we're not going to do it. Okay? Let's look at part B. Again, it just wants us to find the value of x. First, understand what kind of triangle is it?
Isosceles.
Isosceles. So what do we know?
Isosceles.
What can we fill in there? We know two sides are the same. What else do we know? Two angles are the same. These two bottom angles here are the same. So how can I set up an equation to solve for x here? Yep. I know those two angles are equal, so I just set them equal to each other. What is different? I know it's been a while since we've done a lot of algebra, okay? But what is different about this problem that makes it a little trickier and a little longer of a process? We have x's on both sides. Okay, so we got to take care of that first. Does it matter which one we move to the other side? No. Which one do we want to move? I heard the 8.
Why are you listening to this?
4.
How can I move? Majority wins. How can I move the 4 over?
It's positive.
Add 4x.
So you don't have negative.
Yeah, so 9 equals 12x minus 3. Now it's two-step algebra. What's next?
Add 3.
Yep, add 3. So we have 12 equals 12x. Next,
Divide by 12.
divide by 12, x equals 1. If it wanted to know those specific values, how many times would you have to plug it in? Why once?
Because it equals 1.
Because they should be equal, right? Once you find one, you should know what the other one is because they are congruent to each other. Okay? Okay? On this example here, don't focus on the question yet. What kind of triangle is that? Always think of that first.
Isosceles.
Why? It doesn't tell me two angles are the same.
The two angles are the same.
Right. It doesn't have to tell us the sides. It could also tell us the angles. Okay? So since two angles are the same, I know those two sides are the same. Yep. So these two right here are congruent. So I put those markings in there. So A tells us it wants us to find the value of x. Ideas.
They all equal 180.
That would be if they were angles, but they gave us sides.
You make them equal to each other.
Which ones?
8x minus 1, 4x plus 5.
Yep, we know these two sides here are congruent, so we can set them equal to each other. 8x minus 1 equals 4x plus 5. So did I even need to use that bottom one? No. Okay. Which x do we want to move? The 4? Subtract 4x. This is your part A. We have 4x minus 1 equals 5. Two-step algebra.
Add 1.
Yep. Add 1.
Divide by 4.
Divide by 4. Now, when you get to this point, I know it doesn't come out even. If you want to use fractions, you can. If you like decimals better, use decimals. Okay, so we get 3 over 2 or 1.5. Part B says, what are the lengths of all three sides? How do we figure that out?
Plug in X.
Plug them in. Okay, I'm going to label my triangle up here just so I can stay consistent. I'm going to label it A, B, and C. So side A, if I'm plugging it in, I have 8 times 1.5 minus 1. If you typed that into your calculator, you would get 11. B, I have 4 times 1.5 plus 5 equals, what should it equal? Did I even have to plug that one in? No. It's okay if you do, just to check, but why did I not have to plug that one in? Because A and B are equal. Yep. Okay, C, do I have to plug that one in? Yes. So I have 2 times 1.5 plus 11 is 14. Yep. So I found all three sides. I'm done with B. Okay. So all we've been doing here is knowing what, or using what we know about triangles and applying them to find a certain value. Okay. Way back when in chapter 2, we learned that all angles are equal to 180. And now we're throwing in what we know about isosceles triangles and equilateral triangles. Okay. And we're kind of meshing it all together. Okay. One thing that I mentioned a while back that we didn't spend a lot of time on was perpendicular bisectors. Okay. What does the term perpendicular mean? They meet, it's two lines that create a 90-degree angle. Okay, so if you ever see that symbol, that means perpendicular. Okay, what does bisect mean? What do you think of? I see split in two or cross. Okay, it is exactly that. That's two lines that are crossing each other, but it splits it in half. Okay, so looking at this perpendicular bisector, this one, QS, is that perpendicular bisector. Okay, it is. It is. Yep, Q. Since it's perpendicular, that creates a 90 degree. It would be on both sides. Okay? So we have a 90-degree angle there. That's the perpendicular part. What about the bisect part? What happens to PR? What happens to this right here? Splits in half. So do you agree that these two are congruent? Can I put one congruent mark there?
No. Oh, yes.
Why not?
No. Because they're two separate ones.
Why do I have to put 2 marks here? Because there's already a pair. Okay, so we have to keep those pairs separate before you get confused. Okay, well, if one side's 4, what's the other side? 4. Okay, I'm going to ask you this. How many triangles do you see in that picture?
3.
Where's the third one?
The whole thing.
The whole thing. Okay, I want to focus on the whole thing real quick. Big picture. What kind of triangle is the big picture? Isosceles. So we know those two angles here are the same. Well, if one of them's 31, what's the other one? 31. Okay. Now let's take a look at the questions. Measure of angle RSQ. Remember, it goes in order. So we're looking for that specific angle right there. Any ideas? What does that box mean in there that we drew in?
It's 90 degrees.
It means 90. How can I find that angle?
Add 90, 31.
Subtract by 180.
Right. Remember from chapter 2, if we know two angles, we can find the third. So take 90. This is part A. Plus 31, which is 121. And now, how do I find the third? 180 minus 121 is 59. Yep, that's part A. Again, once you find something, I highly recommend you put it in the picture. Highly recommend you put it in the picture. What do we know about angle PSQ?
It's the same to
It's the same, right? Because of those congruent markings. So we know this one's also 59. Okay. Now, I understand these pictures can get a little messy. Okay. Just try to stay organized with your pictures and your drawings. Okay. Last thing, part B. What is PR? Think way back to chapter 1. First thing I ever taught you.
100.
PR. What's the whole length of that? Right. Just add up the two sides. 4 plus 4 is 8. That's part B. Okay. What do you notice about example 6? There's a lot of things going on. There's congruent lines. There's multiple triangles. Okay. We're putting everything we know together. What I always tell people, look at the big picture. What I mean, look at the whole triangle. Okay. MPO, that whole triangle, Is it isosceles, equilateral, or neither?
Both.
If we split it, look at the big picture though. Is the big triangle isosceles or equilateral? It's not either, right? Okay, so now let's look at them separately. I'm going to focus on the one on the left. What do we know about triangle MNP? This one right here. It's an equilateral. Okay, we know that because they gave us all sides are the same. Well, what else do we know?
All angles.
All angles are the same. And Camden, what'd you say? They're all 60. Okay. Do we know anything else about that triangle? No, so let's move on to the other one. What kind of triangle is the other one? Isosceles, because of those two congruent marks. What do we know about isosceles triangles? Two sides are the same, then two angles are the same, those bottom ones. Why did I have to put 2 marks there?
Because you already put the other ones on the equilateral.
Because I already have one, right? Good. Okay, now let's look at the questions they're asking us. Measure of angle PNO. That's this one right here. How'd you get that?
Because it's the same one.
180 minus 60.
Yeah.
How'd you know to do that?
Because the line down the middle is not the...
Right, what do we know about this line right here?
It's 180.
It's a straight line, which means 180 degrees. And then remember in chapter 3 when we talked about, or sorry, chapter 2, we talked about if that's split, all of those angles in there add up to 180. Okay, so for part A, we can take 180 minus 60 to give us 120. So this angle in here is 120. So that was part A. Now part B, we want to find measure of angle NOP. Ideas. How'd you get that?
20, well,
Plus,
it's like half or whatever.
Okay, what do we know about all angles in a triangle?
Yeah, out of 180.
Add up to 180. So let's start there. Let's take 180 minus 120. What is that?
60.
Gets us back to 60. So we know these two angles together equal 60.
So you divide by 2.
Correct, because we know they're the same. So take 60 divided by 2, which is 30. That's part B.